Hi and welcome back. As promised, here is a practical example of using the Modulation Domain Analyzer for actual work. Right here, behind it, we have two processor boards with a connection over Ethernet to a central server that is running a Precision Time Protocol Grandmaster, and these are two PTP slaves. You can see the server is all the way back there and the switches right over it. One of them is what connecting both of those boards, and the server sends out a command at a regular interval for synchronized execution on both boards, and we measure the variation in the interval between readings coming from those boards. The readings are just BNCs connected to those output ports and connected to the instrument. For exact kind of arrangement, I would refer you to my previous blog post. The link is below in description. But basically, we have a distributed execution system that we are testing over here. Here is a small snippet of code running inside it. What does it do? We generate a plan for our so-called site. In this case, it's just these two boards, and we communicate with regular 0.2 second intervals. Same command for time check with base time offset and precision time to execute it. Yes, and here you can see the console logs of these two boards executing the synchronized commands. This is exactly what is getting logged on the instrument. Now if we go over here, we can see it is set up for time interval for separate two channels on the fronts of the signals, plus minus time interval. The inputs are configured for 3 volt threshold for both A and B with some minimal hysteresis to avoid line jitter. And here we have different statistics collected on the data. We can see it's sampled over almost 16,000 samples by this point, and most of them laying pretty close, and with peak to peak deviation of 625 microseconds, which is pretty good. This is for speaker network, so basically the deviation with this kind of precision would be less than, let me see, 15 centimeter. That's a 4-inch or something, and from that, the way to test it further, we build out more switches in the chain, because this switch does not have to end-to-end PTP support, it's just a transparency mode. So what we ultimately want to measure is how it would degrade in a setup with a ring of dozens of switches before we commit to buying a few hundreds of those for a project. So there is not all precision time protocol implementations are made equal, and this one we testing is on the cheaper side. So the instrument, yeah, we can see what time basis, half microsecond per division. The rest we went through. The instrument otherwise straightforward. The functions, the math you want to access is doable with shift here, like we can see rate here. No, rate is for frequency measurements, but let's see standard deviation. 143 microseconds. So basically I get a way to measure delay is to use a scope with two inputs, measure input to input difference, but that doesn't give you much in terms of statistics. It kind of ad hoc way. This instrument is much more precise for this purpose. So let me walk you quickly through menus. Function and input is where we are now. Inputs are configurable here. You fall back to menu here, to function menu. As vertical adjustment, I never really use it. Markers for when you need them, not really useful in an interval mode, but you can, when measuring a single frequency source, you can as well limit the histogram area that is of interest to you. Like if you have some occasional noise outside and you want to sort of measure the bulk of data, you can restrict the analysis there. Time base, 1/2 millisecond per division. Histogram, yeah, we plot histogram. I'm not gonna switch it or it will clear the display. Trigger settings, we run an auto trigger for auto centering with forward slope and HF reject for the signal. The signal could be a bit noisy from switching transistors that are on the input now. Sampling, the user manual doesn't suggest really to change it unless you really want to do something fancy, but it's straightforward. Also counts on 1 inch count on transition. Display, basically a visualization mode. Access, yeah, and utilities, various tests and system settings. This row is just the same as you have on the contemporary scopes and analyzers. Numerical output, function keys, jog wheel, fine button that I never used, fine adjustment I guess on this one. Save and recall, status, you can see my settings right here. Auto scale, thing about auto scale, it doesn't really work on very low frequency measurements like we do now. We are on order of 8 Hz pulses on 2 channels. So below 10 Hz was it? I don't think it can be automatically tuned. So yeah, that's basically it. This one has an option with channel C that allows for RF measurements up to 2.5 gigahertz. That channel, however, cannot be combined for interval measurements. It's only these two. There is an external arm for when you need it. I haven't used it so far. And this unit has also oven stabilized oscillator, which is again less of an issue on these pretty slow measurements we have here. But it's nice to have anyway. I expect to use it for different applications as well in system development, measuring jitter on different clocks and stuff like that. So that was about it. Nice unit if you have it, and has some unique functionality for when you need it.